This week, we speak with Catherine Chambers again and Will Hickie from Irdeto about bringing data science to mobile application security. In the news segment, we sample some unholy guacamole, go from a frying pan OS into a SAML fire, feast on a buffet of buffers and image files, and more. Stay tuned for and stay hungry for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Today, cybercriminals are taking advantage of an expanded attack surface to commit malicious activities ranging from hijacking user accounts to making fraudulent purchases. Businesses need solutions that can protect their sites from this increase in fraudulent activity. reCAPTCHA Enterprise is a frictionless fraud detection service that leverages our experience from more than a decade of defending the internet with reCAPTCHA and data for our network of 4 million sites. To learn more about how reCAPTCHA can defend your website or mobile application against fraudulent activity, visit securityweekly.com/reCAPTCHA. Security threats in cloud-native environments move fast, which means that security teams need to have the same visibility into their infrastructure, network, and applications as developers and operations. With Datadog security monitoring, engineering teams can easily detect malicious activity in real time before it affects their customers. Use out-of-the-box detection rules and detailed observability data in one unified platform to investigate security attacks. See it in action by signing up for a live security demo and receive a Datadog t-shirt by visiting securityweekly.com/Datadog. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/Synopsys to learn more.
Welcome to Application Security Weekly. This is episode 113, recorded July 6, 2020. I'm your host, Mike Shima. I'm here with Matt Alderman. Hey, Matt.
Good morning. Can I have chips with my guacamole, please?
Chips and dip, because we also have a John Kinsella who is recovering, and welcome to Monday, John.
Hey, happy to be back.
We've got you back. Everyone's here. Time for a party. We also have a party if you join the Security Weekly mailing list and receive your invite to our community Discord server by visiting securityweekly.com/subscribe and clicking the button to join the list. With all the recent changes to Black Hat and DEF CON, we realized we can keep doing what we do best, host virtual podcasts. I'm proud to announce Hacker Summer Camp 2020, a Security Weekly virtual live stream event, August 3rd through 6th, 2020. To reserve your slot now, visit securityweekly.com/summercamp2020. We have two guests to introduce today. Since 2011, Catherine has been helping to architect Irdeto security solutions for web, mobile, and embedded systems. She sometimes posts videos for Irdeto on the subject of reverse engineering under the name Cloakware Caked. Prior to joining Irdeto, Catherine worked for many years as a lead programmer in fast-paced startups. Her experience spans the range from coding in assembler to cloud computing. And Will Hickie joined Irdeto in 2018 as a data science architect to investigate how machine learning can be used to improve software and intellectual property protection. Will employs a statistical data-to-outcomes approach to problem solving. With 20 years of software development experience and more than a decade of applied ML, he's able to speak to both engineering and machine learning disciplines, and hopefully us. Will skipped university and went directly into his first startup during the tech boom of the 90s, designing algorithms for real-time surveillance systems. So, Catherine, Will, thank you for joining us today.
Thank you.
Great to be here.
And we're glad to have you, and especially talk about data science and mobile application security and hardening against reverse engineering. But before we get into that second part, let's actually talk about the data science part first, in the sense of, is or how can data science be more than just like a cascade of if statements or some fancy regexes?
Well, look, in the end, you could make it a bunch of if statements. It's just there'd be millions of them, and they wouldn't be really overly meaningful to the human reader. But when it comes to code analysis, we're talking mostly about a natural language processing problem. and code it's far more structured than English or French or Mandarin. It just looks really complicated because most people don't speak code, right? It's a subset of the population. Fortunately, we have the internet and we have public resources where people have been submitting code to repositories for decades and decades. So there is an abundance of data. What's usually missing though is abundance of labeled data, and that's kind of where that's a big part of my job.
So that's interesting. And looking at a lot of I'm going to say data science instead of just ML, since that but data science has been applied to code quality, code security in the past too, right? So this isn't completely new that we're looking at right now, or at least this approach.
Yeah, not at all. I mean, look, the public, when they hear about machine learning, they're often, people are talking about holy grail type things. I mean, image processing is a big one because it looks good in print, especially in websites and graphics. And there's tons of advancements there. In code, though, there's been a lot of research done. Everything from optimal ways to represent code as a vector to even measuring certain things. I mean, MIT's come out with some pretty good research recently, and there's a lot of things that we've been doing behind the scenes. We're not going to publish, obviously, but they're making it their way into our products where we have very specific questions that we want to ask about code. Often these are questions you can answer other ways, but using really complicated or expensive infrastructure, we're looking for form factor. We're looking for sometimes answering things you can't get necessarily from a tool. Maybe you need an expert opinion, it's all there. It's just a matter of measuring it and finding the right way to represent the code in our case. And as I say, it's mostly a natural language processing problem.
Yeah, well, I think the interesting part is, when we think about natural language processing, sometimes we think about what you talked about earlier, the structure of language across different types of languages. Because code has more of a kind of a standard structure to it, or is more structured than certain languages, is that what makes a natural language processing capability so effective when it comes to reviewing code?
Yeah. So look, that was one of the first questions I had to answer when I started this was, how analyzable, how statistical is code. When I talk to some people, especially guys who've been, working in a lot of different language over many, many decades, people think there's an infinite number of ways to write a single block of code. There's, hundreds and hundreds of ways to do a while expression. By the time we kind of started really digging into it and actually measuring this stuff, it's like, there's three types of loops people write, 99% of the time. There's a lot of reuse. So there's a lot of patterns that are very common. Even when you start looking at things like how long is a function call, there's some patterns there. Like 90% of functions fit into, so what's the term I used to use? Like the average desktop icon contains more information than 95% of code functions. So it's not this insurmountable problem that it looks like on the surface.
Now, and as you're starting to dive in from the surface into the code, and a lot of this relates to, for example, the OWASP mobile top 10, and some of it is the code quality, but it's also code tampering and countering or hardening against reverse engineering. So now that you have, and you mentioned too, possibly need to talk some more about labeling the data. It's one thing to have data; it's another thing to have interesting data or labeled data, as you said, perhaps more accurately. What are we starting then to solve here? What are we collecting this data for so that we can apply these data science problems to these mobile security, to use the broad umbrella term at the moment?
Yeah, that's the $1 million question, right? Like, what is security? It's a very, very broad concept, and if you ask different people, you might get different answers. Let's go back to labeled data, though. So most people think that they have lots and lots of data, and it's true. They have data, but the problem is for machine learning, you're trying to find some relationship between that data and a given outcome. And that's where things need to be labeled. So in our case, one of the things we're interested in is security value. So you've got all this code. Well, how important is one section of code relative to another when it comes to security? And when you start talking to different companies who have different goals, you're going to get very different answers again. If you ask a cryptographer what's important, they're going to obviously key in on cryptographic algorithms and keys. If you talk to a digital entertainment company, they're going to be talking about digital rights management. So, the term of security is kind of relative to different people and different business cases and what they're trying to protect. In our case, what we ended up doing was conducting a survey. We have a company with many different security engineers with a broad range of expertise in different industries. And so we surveyed them. It was expensive and time consuming, and we got their opinions like tediously on individual snippets of code, and asked them, 6 ways from Sunday how they might think about that code. And then we began modeling it. And, it wasn't really, initially, it wasn't even trying to answer the question of what is security. It was, what do we mean by security? And kind of once we started getting our head wrapped around that, then we could start building models that maybe answer different questions or tell us different things about different aspects of security.
So for the ML folks out there, if I translate that, sounds like you basically, it's not basic, excuse me. It sounds like you crowdsource the categorization and creation of those labels, and then are using that as input into your models, or at least a starting point?
Well, crowdsource is, internal crowdsource, I suppose. Security is a niche field. Most people don't have security engineers. We're very fortunate at Irdeto to be, have all sorts of people with deep and broad expertise in the security realm. So, we basically paid for it in lots of pizza and tons of pestering by email.
Yeah, that to me, that's interesting. Where I was going to go before you started talking about that, once you mentioned labeling, it caught my interest. I was going to wonder if you were doing auto labeling or something like that. And I know we're getting a little off AppSec Weekly, but soon we need to have Machine Learning Security Weekly. That's super expensive to do. I don't know if people fully realize, because to get people and actually get their time to be able to label enough of that data so it's useful for you to have something to do the crunchy with. That's
It really helps if I was going to say it really helps if you gamify it and you make prizes and you have a leaderboard. You get a lot more effort from the people involved when you give them some bragging rights for their contributions.
Yeah, so we constructed a web app that would even tell you, like, so and so has ranked X more samples than you. Maybe hurry up a little bit. So, I had a thought and I just lost it. Anyway, we'll keep going.
Yeah, but like you said, you have to have that internal. You have to have a trustable group of folks that you can give that data to and get the responses back. And then the web app sort of is the sugar on top. But cool.
Yeah, and I think.
Go ahead, Catherine.
Yeah, I was just going to sort of talk a little bit about the drivers behind why we did this. Because we do have security experts in house, and we're limited to the number of projects and security advice we can give, the number of people we can help with their apps if we have to do it all manually. So that was the real impetus behind it. How do we create a model that can do some of this on behalf of us, so we don't have to get people working full time on helping people protect their mobile applications. So we had to go through this big effort. It was labor intensive. It did take many months, but it was important if we wanted to be able to help a lot of people with their mobile app security problems.
Right. Yeah, so because if you try to do it with people, it just doesn't scale, right? So.
Well, that's the industry as it stands. It's trying to do it with people, right? You have security engineers who have a lot of experience, and they're very expensive, and they analyze code. If you start thinking about a code project that has 5 million lines of code, and it costs you 3 cents per line to have someone have an opinion about it, it starts to get really expensive. One thing that might be interested to some of the other data science folk, before we even started down this road, we did run experiments to help us figure out how much data we would need ahead of time. So we did a lot of research before we even started, asking people questions about code. Because if this is a type of thing where we would have needed, 20 million labeled code samples, we might have had a different type of problem. But to Catherine's point, like, applying security isn't difficult in the sense that you could just encase something in a big block of concrete and then sink it in the Marianas Trench, and then no one's ever going to touch it, right? So in that sense, something can be really, really secure. But that's really not what anybody actually means when they talk about security. It has to be usable. So when we're talking about security, what we're really talking about is applying a budget. And everybody has a budget. It could be 5%, it could be 100%. Sometimes that budget's about speed. Sometimes it's about size. And that's really the end product of what all the machine learning work is doing, is providing us with a set of numbers we can use to then hopefully budget security around an application to provide it, as much as is possible, given what someone wants to spend on it. And again, back to performance, size, and a number of other factors.
And I think that's what emerges too, is that the human part of the analysis would be that, you don't need to go through and spend a lot of time hardening the GUI elements of the app, for example. But you probably, as you mentioned, want to touch on the crypto aspects, or if it's a network and has a custom protocol, or even just a re-implementation of an open source protocol, that's where a lot of flaws could come from, and that's where the security analysis needs to go too. So hopefully, it also sounds like you don't necessarily need that 20 million, then 20 million plus one number of apps. You just need to be able to look into the app to figure out, is this relevant to where I want to spend my budget? That's I think what sounds like the case here that you're really building for this type of approach.
Yeah, you nailed it, right? Like, it's for any given application is really about kind of ranking all the different code elements in order of sensitivity, to whatever your security requirements are. The network stack's a really good example because, it's super, super important. But it has a really funny interplay with things like performance. If we start putting heavy encryption or some other techniques on that networking stack, your application will become unusable because it's going to take seconds of processing just to send a few bytes. So it's this weird dance between understanding where the critical parts are and where the parts are that you're actually allowed to do something with them.
So speaking of allowed to do something, or even speaking of budgets, so attackers have their own budgets too. So sort of kind of opening up a little bit about, often, an ML system might just be a black box. Data goes in, something happens, data comes out. In a way, that's what's happening here. So with an app, with a mobile app, so how could we sort of measure or kind of evaluate that this budget is either being well spent, or what we want to try to perhaps optimize for? What's a way we should be thinking about that?
Yeah, so in our case, Irdeto has technologies that's built over decades to provide, code level security. Some of these things include white box cryptography. Some are anti-tamper protections. Some are things to make analysis very, very difficult, to hide your data, protect your data, protect control flow. So these protections already exist, and we can kind of tune them in terms of, how complicated, confusing, or how horribly we want to make life for somebody who's trying to reverse engineer these things. And a lot of them have already been proven out by security engineers because, for years, people have been applying these things by hand. We have somebody go in and look at a code project, and they'll figure out the best way to set this stuff up. The machine learning isn't actually creating the security. All it's doing is these models are telling us how we can apply these existing technologies we already have in a way that's going to meet that budget. So, if you say you want a 10%, whatever we're going to talk about, any axis of budgets, if you say 10%, we know we're going to spend that 10%, right? In terms of what does that mean in security, we have to really get into a deep dive at that point about how some of these different security features work. And that might be outside the scope of this conversation.
Maybe it's worth talking about a little bit about, Will, about the various models that we created, or you created, because of course we had to get all that nice labeled data for you to identify security sensitive pieces of code. But as you said, we have a budget, so we had to create another model as well. Maybe you want to talk a little bit about that.
Well, there's quite a few actually. So there's performance is a big one. So we have models that can read raw source code without executing it, without running it through anything. They can give a very surprisingly accurate estimate of how expensive that code is in terms of CPU cycles. In some cases you can even target it to processor. But then we can also estimate what's the cost going to be if we apply some of these different security features ahead of time. And that's really, really important because, if anyone who's been involved in software development knows building and testing your code is extremely time consuming, and it's really, really resource intensive. in our case, having an automated environment where we can build and test your code might not even be feasible in some cases. So having models that can read code and then tell us ahead of time, if we apply this security feature, the impact of the code is going to be X, absolutely critical. And again, surprisingly, these are very solvable problems, because we're not talking about code autocomplete or, what's the best way to write an application. These are things that we've been able to measure internally because we have access to test sets and we have access to these tools. And so building that statistical model using, very precisely labeled data and tons of it, it was possible.
Well, it sounds a lot like you're taking that concept of like LLVM, for example, has address sanitizer, undefined behavior sanitizer, all these sanitizers that it will actually apply during the compilation process. And in those cases, it's actually looking for very specific security properties or just code quality properties. But you're kind of, it sounds like, taking that approach and saying, what can we do to change the control flow to add this add a performance impact perhaps, but below the acceptable budget that will also have an impact on the time it takes to reverse engineer or analyze that section of code?
Yeah, absolutely. So in some ways, it's like this is like reverse optimization, but we're optimizing for difficulty to understand or reverse.
So then then I guess, let's see, looking at that idea of like reversing in the attacker cost, what are some ways that either someone looking at this could validate either I'll say the correctness, or should there even be concerns about correctness of how this binary is transformed into a hardened version, or how effective it might be?
Well, look, the easiest and probably the most effective way is to reverse engineer the binary, try and break into it. That's going to be the most effective way. The problem with that is most people just can't afford to do it. I mean, that's kind of the heart of all of this, is most people can't even afford to apply security. Security engineers are difficult to get a hold of. They're in short supply. So yeah, testing it out is one thing. I mean, there are empirical measures sometimes, like how long does something go to market before you have an issue. But you could do small unit tests on individual functions. But again, like there's a reason we automate this stuff. When you start looking at millions and millions of lines of code, it doesn't really become feasible anymore to have an individual go through and look at every single thing. You're going to have to put some trust at some point into the system. And I would argue that people already have. I mean, by the time you're compiling code, people aren't looking anymore. They're letting a compiler make millions and millions of decisions about how they're going to transform that information, and you're trusting that it's going to work, and it does.
So Will, as you think about, sorry, Catherine.
Go ahead.
Go ahead.
Are you sure? Yeah, I was just going to say it is labor intensive and time consuming to do a security audit every time you modify your app, and in the case of mobile app development, it happens quite frequently. There are some app producing houses that will publish a new app every few weeks because they're updating new features or they're responding to customer feedback. So it becomes impractical to do that kind of manual security audit every time they want to make a change.
Yeah, I agree. But I'm curious if there's been some patterns, like best practices that come out. So for example, if we think about the attacker costs, right? How long should a mobile app be refreshed to limit the amount of potential time for a hacker to hack it? Because internally, I may not have the resources to spend the time to do a reverse engineering on my binaries, but as an attacker or a hacker, I might, right? And so are there like windows that say, if you're refreshing your mobile app every 30 days, that keeps the attackers away because there's enough change in the mobile app to keep the cost too high for attackers to go after it? Do you see some of those patterns and kind of best practices coming out of the analytics that you're doing on the data science side?
Maybe I'll jump in on this one, Will, because I have a very strong opinion on this. And as you alluded to, once an app is released, it's out there. And it doesn't matter whether you update it on the App Store, that an original version can be out there, it can be downloaded, and people can reverse engineer it. So I'm a strong proponent of applying application security from day one, so that you're, as you say, because once it's out there, then it's out there. And any secrets that you thought thought you'd protected or thought you'd any algorithms or data or anything that you want to keep a trade secret, you need to keep secret from day one. So in terms of best practices, I would certainly recommend doing up the kinds of code protections that we do right from the start.
We've also, so I want to throw in, so there's DevSecOps is one of the great terms that we've been bandying about on the podcast for ages, and the industry has. But let's not forget the dev part of this cost too. Like, so if the security team comes and says, we want to have a security budget to counter reverse engineering, protect us from tampering, what's the developer cost if they need to introduce this type of approach or this type of tooling into their process?
Well, this is the whole benefit of ML, right? And as I said to Will the other day, that the whole goal is to be able to do this, quickly and at scale. So because of the models that he's built and his team have worked on, they're able to process, as you mentioned, the input into our algorithm is the intermediate representation of LLVM, LLVMIR. So this is a format that is produced when you build an iOS app, when you create an XC archive file, that's what you get. This is what you upload to the App Store. So we have models that can parse this automatically. We actually don't need any effort from the developer. And then, all this expertise, all these expert thinking that Will has modeled can be automatically applied. It will automatically recognize which pieces of code are security sensitive, which pieces of code aren't, and which pieces of code are likely to have a big impact on performance. And then it becomes a math problem that we're able to use nice cloud computing resources to help solve for us.
Right, so it sounds like it's definitely built down or turned into, here is the drag and drop to harden, and it's not going to harden the UI, so it's going to slow that down, because who cares about a hardened UI in the sense of protecting against reverse engineering, because the UI needs to be crisp and be responsive. Otherwise, it goes to the classic, the network is slow sort of user complaint. So that's really that. So hearing that sounds a lot easier and a lot more compelling for developers, because they don't have to necessarily adjust their process much, if at all, other than we upload to the particular app store, and we now have an upload to the hardening step, then the store. So pretty easy step, it sounds like.
That's right. Yeah, we have our backend APIs, our REST APIs that you can hit with your CI/CD system to, make app hardening just a part of your development pipeline. But one of the interesting things about it is that because we don't actually need any input from the developer, it's something you could do as a completely independent step. Sometimes our customers actually outsource their app development to third parties. And those third parties potentially aren't interested in learning security or applying security. But this completely decouples the app development effort from the security effort. And that enables businesses to quickly apply security without either contracting people to do it or learning how to do it themselves.
Right. So you're just inserting that extra kind of hardening step in between build and before you kind of ship it or put it out there in the App Store. It's just a simple step. And whether you're doing the build process or somebody else is doing it, you can still take the hardening step and that final publishing step for that mobile application.
That's right.
Yeah.
We also we've been talking about, you mentioned too, Catherine, about, investing in security in general for the applications. So and with a sort of looking at this from a threat modeling perspective, there's also a lot more there are additional aspects of the OWASP mobile top 10, for example, or other concerns that you would have on the app. So this wouldn't, for example, this isn't supposed to try to protect you from devices that are necessarily rooted to have a keylogger or something like that might actually be an overlay on the UI. So it's also good to have an idea of what we're protecting against, as well as to a degree what we're not protecting against, just so we don't misuse or misunderstand the purpose of these tools.
Yeah, no, that's true, right? Security or defense is really a multi-layered thing, right? And we see this as complementary to a lot of the other security best practices out there. So certainly, making sure that you have anti-malware on your phone is a great idea. But this this is to protect against a different category of attack, about somebody who, even in the presence of malware, even in the presence of something that has compromised the device, making sure the application itself is maintaining its secrets and keeping its integrity.
Yes, yeah, definitely hitting that.
The secrets are the kind of the important part, from this perspective. It's the guts of your application, and that could be a cryptographic key. It could be a cryptographic algorithm. It could be digital rights management. It could be license management. It could be anything. But kind of as Catherine's saying, like we focus on the code aspect of things. I mean, but security it's layered, right? Like if there's people involved, that's a vector too, right? So we specifically look at the part where an engineer is writing code, and that's where we can augment and assist. And there's no replacement for a broad security-minded organization really thinking about things from the top to the bottom. But we plug into that one area, the software development side.
Mm-hmm. And you don't need to augment and assist the developers. You don't need another couple 1,000 or million apps to improve the models. You just need that expertise to label it. So looking forward to augmenting and assisting these developers, what are some upcoming things that we could be looking forward to from capabilities of hardening these apps?
Oh, I guess that's a product management question. So I guess I'll add that. So of course the dream would be to make this an AI-driven system. That's not where we are today, of course, but it would be really great if we could get to the point where the system was learning and improving as it went. That seems a little. I mean, as much progress as we've made, that seems like a few steps away from us still. But the really exciting new developments that we're working on now are to automatically inject little snippets of code into the application to do things like detect for rootkits or jailbreaks or some of the other platform modifications that might indicate a risk to your mobile application. And that's kind of our immediate term direction is to increase those number of injections and those kind of the sort of forensic detection that we can automatically do of the device and how it may have been modified by the user.
That's pretty cool, because that sounds interesting. Because if you're transforming a control flow to make it harder for humans to analyze, that also, as you're describing, that also sounds pretty cool. That why not also transform it and inject some additional detections for forensics? So that sounds like a pretty natural evolution.
I just want to add some spice to that, because like when I first started at Irdeto, I was looking through experimenting with the toolset kits, and it's something else to have an application actively crash your debugger. It's really neat. It's neat to see.
And Catherine, with those pieces of code, those forensics tools in there, does that now allow you to start to close the loop a little bit when we think about what other detections you have? Does that help to improve the models for the protections and kind of closes that loop between what you're doing on the protection side with some of the active monitoring in the application when it's actually running?
Not at the moment. I think you're helping me brainstorm future product ideas, but at the moment, no. It's just passive reporting. I think the way you're thinking is kind of how we're thinking, right? Once Will and his team started work on this, and we kind of saw the things that were possible. Once you're able to start treating code as data, once you're able to take even compiled code and start to model it and make reasonable decisions based on just inspecting the binary. Really, the sky's the limit. There's nothing we can't do. It's just a matter of getting the data that Will is always asking for.
Or it's a matter of budget, because now you need some more data scientists and resources back there to work on it, right?
Yeah, well, there's the things that we already have tools to measure, and so in that sense, it's almost it's a tap we can turn to get data. But then there's the more difficult things, like the human expertise. I mean, security engineers it's a specialized field. Not everybody's good at it. The people who are good at it are it's complicated. It's really, really complicated, and understanding how they think and what their thought process is it's not easy. we could probably try and pick their brains for the next 100 years, and there still wouldn't be enough data.
No, well, thank you, Will. Thank you, Catherine, for joining us so we could pick your brains about this topic. It was really interesting for us.
Thank you.
Thanks so much.
Well, thank you for having. Thank you again. And if you'd like to learn more about Irdeto, visit securityweekly.com/Irdeto. And I want to thank all of our listeners. I want to, of course, also thank Matt and John. And we are going to take a quick break. And then we'll return with news of the week.